Alright, in this video, I'm going to show you how to use your knowledge of trig functions to work backwards and find the missing angle that would give you this answer. Now we're only talking about angles between 0 and 2 pi. So look, for starters, cotangent is a reciprocal trig function. So the first thing I would do is convert this to the regular trig function. So cotangent is the reciprocal of the tangent function. So that means if cotangent is equal to radical 3, then the tangent is going to equal 1 over radical 3. Okay, well, what angle has a tangent of 1 over radical 3? So here are here's a table of values that you basically should have memorized. Now in a previous video I mentioned that really these three yellow values are the three that you have to memorize, and then after that you can go, okay, the cosine of pi over 4 is the same thing as the sine, so you have that. For pi over 3, these are just the reverse of the pi over 6's, so you get those. And then tangent is just sine over cosine. So if you divide, you get 1. If you divide 1/2 over radical 3 over 2, you get 1 over radical 3. And same thing here. If you do radical 3 over 2 divided by 1/2, sine over cosine, the 2's cancel out and you're left with radical 3. So you should be able to generate this chart in about 1 minute and 30 seconds. So anytime you have a trig test or a quiz or a big assignment, the first thing you should do is take out a half sheet of paper and just generate this chart and then use it for all of the problems. So from now on, for the rest of this video, I'm going to assume that we have this chart produced and we're just going to refer back to it. So the tangent of what angle is 1 over radical 3? Okay, so here I have 1 over radical 3. So I know that the tangent of pi over 6 is 1 over radical 3. Okay? Now, that doesn't necessarily tell me the answer. That just tells me the reference angle. Okay, the reference angle is pi over 6. Because the reality is there's more than one angle that has a tangent that is 1 over radical 3. So we have to find out. So we know that the tangent of pi over 6 is 1 over radical 3. But there are other angles that have a reference angle of pi over 6. So what I recommend is drawing a diagram. So here is pi up top. Now, if the reference angle is pi over 6, I'm going to split this up into 6 pieces. So here's how I do that. Alright, obviously this is not perfect, but you can see in the top half I have 6 pieces, so each one of these is pi over 6. Now the point of that is these are the 4 angles that have a reference angle of pi over 6, because remember the reference angle, that's the angle against the x-axis. So the tangent of any one of these is going to give me an answer of 1 over radical 3, except 2 of these will be positive and 2 of these will be negative 1 over radical 3. So another thing that you should have memorized is where tangent is positive, what quadrants. Turns out tangent is positive in the first quadrant. All right, everything is positive in the first quadrant. Tangent is positive in the third quadrant, and tangent is negative in these 2 quadrants. Okay, so we want a positive result, positive 1 over radical 3. So that means this angle and this angle Okay, those are the two positive ones. So those are going to be the two solutions for theta. Okay, so sure, one of those turned out to be the reference angle of pi over 6. Okay, but we also have this one over here. So what's that? Well, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So 7 pi over 6. So those are the two answers to the question. Okay, let's look at number 28. We want to find theta, where the cosecant of theta is equal to 2 radical 3 over 3. This is a reciprocal trig function, so let's start by converting this over to a regular trig function. Cosecant is the reciprocal of sine. So that means that the sine of theta must equal 3 over 2 radical 3. Now, I need to know what the reference angle is, and when I look at the chart of values that we have basically memorized, I don't see 2 radical 3 over, what was it? I don't see 3 over 2 radical 3 anywhere on the chart. Well, the problem is this is written in a weird way. Let's rationalize the denominator and see what we have. So what do I mean? I want to get rid of this radical. So I'm going to multiply by radical 3 in the top and in the bottom. Okay, that's going to help me see what I'm really dealing with. Okay, so now I have 3 radical 3. Now down here I have 2. Now radical 3 times radical 3 is 3. Okay, now these two radical 3's are going to cancel each other out. So that leaves me with sine of theta is equal to radical 3 over 2. Now can I find out what the reference angle is? Okay, radical 3 over 2. All right, that's the sine of pi over 3 is radical 3 over 2. So that tells me that pi over 3 is the reference angle. Okay, so let's draw a picture of a bunch of pi over 3's. Let's draw a diagram. So here's pi. I'm going to divide this up into 3 pieces so that I will have pi over 3. Okay, and what you need to focus on, reference angle. So that means here are the 4 angles that have a reference angle of pi over 3. Now the significance of this is the sine of any one of these angles is going to give us radical 3 over 2. Except for one thing, 2 of these are going to be positive and 2 of them will be negative. So this is a positive radical 3 over 2. So I need to know which ones are positive. Well, check it out. We're talking about the sine function. And on the unit circle, the sine function is the y-coordinate. So the y-coordinates are positive above the x-axis and negative below the x-axis. So the sine function will be positive up here and negative down here. So because we want the positive answers, then we are talking about these two angles. All right, so now we're ready to say the solutions. So what are these two angles? Well, theta is either going to equal so this first one is just pi over 3, all right, which was the reference angle itself. But the second one is 2 pi over 3. All right, 1 pi over 3, 2 pi over 3. Okay, so that is how you can work backwards and find the angle. There will usually be two answers. Okay, what about 29? Okay, this one's a little bit different. I can tell by the answer that this is a quadrantal angle, meaning this angle is going to land right on one of the axes, the x-axis or the y-axis. Let's go ahead and get our diagram going. Okay, let's think about the coordinates of each one of these quadrantal points. Imagine this is the unit circle, okay? So this is the point 1, 0, and this is the point 0, 1, and this is the point -1, 0, and this is the point 0, -1. Now, each one of these points is in the form cosine, sine. Okay, so basically, sine is the y coordinate. So we want an angle where the sine is going to be -1. So we need the y coordinate to be -1. Well, there's only one place where that's going to happen, and that's going to be right here. This is the only place where the y value is -1. So what angle is that? Well, these quadrantal angles are at pi over 2, multiples of pi over 2. So like this is 1 pi over 2, 2 pi over 2, 3 pi over 2. So that's the answer. So the only angle that has a sign of -1 is 3 pi over 2. Okay, one more. All right, the secant of what angle is 2? Well, this is a reciprocal trig function, so the first thing we should do is convert this to a regular trig function. Secant is the reciprocal of the cosine function. So that means the cosine of theta must equal 1/2. So let's look at the values that we have basically memorized and look for the reference angle. So we need the cosine to be 1/2. Okay, well look, cosine of pi over 3 is 1/2. Now that doesn't tell me the answer, that just tells me the reference angle. Okay, so right now we know that the reference angle is pi over 3. So to know exactly what the answer or answers are, we need to draw the 4 angles that have this reference angle. So pi over 3, so that means I'm going to take this pi and I'm going to split it up into 3 parts. Okay, 1, 2, 3. So each one of these is pi over 3. So these are the 4 angles that have a reference angle of pi over 3. Here, 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 and here. Because these are the reference angles against the x-axis. So that means because all 4 of these have a reference angle of pi over 3, the cosine of any of these is going to give me some kind of 1/2. Except for 2 of them will be positive and 2 of them will be negative. So where is cosine positive and where is it negative? Well, remembering that on the unit circle, the cosine is the x value. So the question is, where are the x values negative? And so, x values are positive on the right and negative on the left. So these 2 angles will have a positive cosine, and these 2 angles will have a negative cosine. So for this particular problem, we want the cosine to be positive 1/2. So these are the 2 angles that are the answer. So that means theta is going to equal, this first one is simply pi over 3. What about this one? Well, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, and that's it for this video. In the next video, I'm going to show you how to find the arc length in radians. It's pretty easy. So if that's something you want to learn, I will see you on the next video.